everybody. Today is Monday, November 14, and I haven't graded your quiz yet. I'm gonna grade today and tomorrow, and then we will go over that on Wednesday. So today, I will try my best to finish 6.2 and 6.3. That's why I give you this handout. Okay. And this Wednesday, we will have quiz 7 on 6.1 to 6.3. So hopefully, after today's class, then you'll be prepared for the quiz. And when is our exam? Next Monday, before your Thanksgiving. So during the break, you can enjoy your break without thinking about math. And Wednesday night, we have a review session at 8 p.m. Okay, so we will go over your practice exams together. So I hope, after today's class, you can work on your practice exams, and then so when we go over that on Wednesday, you can ask me questions and understand more. I hope you can practice before we go over. Okay, that's our plan. And so let's start. Okay, so look at the handout. Okay, so what are the formula we learned? This hexagon, the way we write it, sine, cosine, tangent, cotangent, secant, cosecant, and we put 1 in the middle. Hi, we have a handout today. Okay, the diagonal formula. There are 3 diagonals. We know the product of the 2 ends is the middle one, right? Hi, we have a handout today. Okay, so therefore, this diagonal, what do you get? Sine x times cosecant x equals to 1, right? So sine x and cosecant x, they are reciprocal of each other. And then look at this diagonal. Bless you. What do we know? Tangent x times cotangent x equals to 1. Right? Hi, we have handout today. The last diagonal, what do you get? Cosine x times secant x equals to 1. Right, everybody? So be familiar with the trig identities. Very, very important. That's the basic of exam 3. You must memorize this. Okay, and then there are 3 upside down triangles. We have the sum of the upper 2 endpoint square equals the bottom endpoint square, right? So therefore, this triangle, what do we get? Sine x squared plus cosine x squared equals 1. Right, everybody? And by the way, you probably want to put a parenthesis around it because you mean cosine x. And then this whole thing square instead of, so you don't mean sine x squared. You don't mean that. Right, everybody? Okay, and how about this triangle? Tangent square plus 1 equals secant square. Yes, everybody? How about the last triangle? Yeah, cotangent square plus 1 equals cosecant square. Right, everybody? So these are the 6 trigonometry identities. We must memorize it. And also, you know, sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse, right? And tangent is opposite over adjacent. And then, hi, we have handout today. Yeah, we have handout today. Okay, and then, you know, cotangent, reciprocal of tangent, therefore adjacent over opposites. And secant is the reciprocal of cosine. So hypotenuse over adjacent. Cosecant is the reciprocal of sine. Therefore, hypotenuse over opposite. Okay. And then this table. So everybody make sure you can fill out all this value and formula by yourself, because those are the basic of exam 3. You need to know those. Okay, these are the special angle values. And remember the rule I told you? Let's figure out the sine. The sine value, the rule is square root of n over 2. And you let n be 0, 1, 2, 3, 4. Do you remember that? Therefore, sine of 0 is 0. And then 1/2. And then yes. And then 1. Exactly. How about the cosine? Same values of sine, but reverse order, right? So you copy reverse order. So 1, root 3 over 2, root 2 over 2, 1/2, and 0. Hi, we have handouts. Come on, pick it up. Yeah. Everybody okay? And then how about tangent? We know that is sine over cosine. So 0 over 1 is 0, right? And then 1/2 over root 3 over 2. The half cancel. We get 1 over root 3. Hi, we have handout today. Yes, everybody? And then, oh, pi over 4. Do you see same thing? When we divide it by it, we get what? 1. Hi, we have handout today. Okay, how about pi over 3? Root 3. Yes, everybody? And last one. 1 over 0 is undefined. Right, everybody? Okay, cotangent is the tangent values but reverse order. So undefined, root 3, 1, 1 over root 3, and zeros. Right, everybody? Okay. Secant is 1 over what? Cosine. So cosine is right here. 1 over 1 is 1, right? Think about the reciprocal. Reciprocal of 1 is 1. What's reciprocal of root 3 over 2? 2 over 3. And reciprocal of, hi, we have handout today. Reciprocal of that is root 2. Yes. Reciprocal of 1/2 is 2. Reciprocal of 0, see? It's like 1 over 0. So also undefined. Yes, everybody? Okay. So this is how we figure out the tangent values. Sorry, secant values, I mean. How about the cosecant? Same values as the secant, but reverse order, right? So we have undefined, 2, root 2, 2 over root 3, and 1. Okay, right, everybody? So this table, you gotta memorize it. Okay, because in the exam, the first problem is calculate those values, give exact answer, which means you don't use your calculator. These are the exact answers. Okay, so don't give me decimals. And so these angles is from 0 to pi over 2. Okay, attendance. Okay, so these angles are between 0 and pi over 2. if your angle is in other quadrants, so this is quadrant 1 angles. If your angle is in other quadrants, you gotta find the reference angle. And depends on the trig function in that quadrant is positive or negative. You figure out the sign. Right, everybody? Mm-hmm. So yeah, today this is like a review as well. So this values take care of the theta is from like 0 to pi over 2. That's quadrant 1. Okay? If your angle is in quadrant 2, if your angle is in quadrant 2, okay? So your angle is quadrant 2. Then let's say this is theta prime. Then you know theta prime is gonna be, so this is quadrant 2. You know quadrant 2 is from pi over 2 to pi. Right, everybody? So then your theta is gonna be pi minus theta. So this is the reference angle. Reference angle is always between 0 and 90 degrees, okay? And so you figure out the reference angle, and then the sine is either. Oh, thank you. You're so sweet. Okay, so right, our sine of theta is gonna be plus or minus, either plus or minus sine of the theta prime, and plus or minus depends on which quadrant it lies in. Questions? Oh, one close up there. Quadrant 2, quadrant 2. Okay, quadrant 1 is from 0 to pi over 2. Hi, for those of you coming late, we have handouts today, so come and pick it up. And don't forget to watch the recording. Okay, so this is this is quadrant 2. Quadrant 3. Okay, so quadrant 3 is between what? Pi to 3 pi over 2. Yes, everybody? Let me make it bigger. And this is the theta, then our theta prime. Our theta prime is theta minus pi. And then your trig functions is either based on, because it's quadrant 3, is either plus or minus. It's based on the trig functions, right? And then the last one, quadrant 4. Okay, quadrant 4. This is the theta, and this is theta prime. Therefore, theta prime is 2 pi minus theta. So are you okay with all of those? So quadrant 4 is like from 3 pi over 2 to 2 pi. Yes? Right, everybody? Do you remember those reference angle? Okay, so please come on Wednesday night when we do the practice exam problems. We will talk about this again. Okay, but we gotta keep going. Review your notes. Yeah, we talked about the reference angles before. Okay, so how about the graph of trig functions? We say for sine, 5 key points. They are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember sine and cosine? I tell you they're a wave. Your sine start with the origin, right, everybody? So it starts with the origin. So it's then 0 and then 1, 0, -1, and 0. Okay? So 0 and then pi over 2, pi, 3 pi over 2, and 2 pi. So that's 1. So 0, 1, 0, -1, and 0. These are the 5 key points. Make it better. So far, so good? This is how you draw the sine function. And last time we said if you have a more complicated sine function, you're going to do the table. This is the x value, and this is the y value, and then your theta is going to be in terms of x. Yeah, so review your notes. Okay, we will do some exercise later as well. Okay, cosine. Also 5 key points. They are the same as before, 0 pi over 2, pi, 3 pi over 2, and 2 pi. And the cosine start with what? 1. So 1 and then 0, -1, 0, 1. Yes. So 0 pi over 2, pi, 3 pi over 2, and 2 pi. Yes, everybody? And we start with 1, and then 0, and then -1, and then 0, and then 1. Everybody okay with that? Connect them smoothly. So connect them smoothly. This is the graph of cosine. Okay, so this is what we learned before. Today, let's do tangent. Tangent, the 5 key points are minus pi over 2, minus pi over 4, 0, pi over 4, and pi over 2. Okay? And at negative pi over 2, we get vertical asymptote, so undefined. At theta equals pi over negative pi over 4, tangent is -1. And tangent 0 is 0. Tangent of pi over 4 is 1. Tangent of pi over 2, vertical asymptote, so undefined. So that's why you have 0 in the middle. And then plus 2, this is pi over 2. We have a vertical asymptote. So you draw a vertical dashed line. And this is pi over 4. And this is negative pi over 2, negative pi over 4. So we have a vertical asymptote at negative pi over 2. That's why we also have the vertical dashed line. Now, but 0, 0. Negative pi over 4, we get -1. And undefined. So when we connect them, it's like that. When theta equals pi over 4, tangent equals to 1. And then, so we connect them. We get a picture like that. Okay. Let's draw better. So, okay. Like that. My finger is shaking. Okay. Okay, like that. So this is tangent, and you see it's approaching to the vertical asymptote, but it never crosses, just approaching to it. Okay, cotangent. Also 5 important points. They are the 0, pi over 4, pi over 2, and 3 pi over 4, and pi. By the way, for sine, the period, what's the period? 2 pi. And therefore, if you have more than that, you just keep going, right? And also cosine, what's the period? 2 pi. Therefore, you just keep going. Tangent, what's your period? Pi. Therefore, you have a lot of copies of those, right? Yes, everybody? Okay, now cotangent. Cotangent at 0 is undefined. At pi over 4, we get 1. At pi over 2, we get 0. 3 pi over 4, we get -1, and this is undefined. How do we get those values? find here. See? At 0 is undefined. At power 4 is 1. At power 2 is 0. And in quadrant 2, you are using the reference angle to get those values. Because remember, the quadrant 2, the sign is positive, the cosine is negative, the tangent is negative. The cotangent is negative. Alright, everybody? So you can use the reference angle and then to figure out those values. And then these are the 5 numbers you need to know. So at 0, undefined means there is a vertical asymptote. And then we have pi over 4, pi over 2, 3 pi over 4, and pi. At pi undefined means we also have a vertical asymptote. And then at pi over 4, we have 1, so 1 right here, and then 0, and then -1. Connect them smoothly. Oops. Connect them smoothly. Okay, so this is the cotangent. What's the period? What's the period? Pi, exactly. So therefore, if you want to draw more copy, it looks like that. This is not very pretty, like that. Okay. So far, so good, everybody? So these are the points remember. You need to remember. Yes. Okay. Secant. Secant is 1 over cosine. Right, everybody? So our special value for cosine, they are 0 pi over 2, pi, 3 pi over 2, and 2 pi. And usually, how do I draw secant? I draw the cosine first. And then I remember 1 over cosine is the secant. So I flip it over. Okay, so draw the cosine first. So cosine is wave, but it starts with what? 1. So pi over 2, 3 pi over 2, and 2 pi. Cosine start with 1, 0, -1, 0, and 1. So this is cosine. Okay, so what is secant? 1 over cosine. So 1 over 1 is 1. Here, cosine is 0. 1 over 0, undefined. Therefore, we draw a vertical asymptote. 1 over -1 is -1. 1 over 0, undefined. Okay, and therefore, and then at the end, at 2 pi, 1 over 1 is also 1. So therefore, draw it. The asymptote, so we're approaching it. Bless you. So the blue curve is the graph of secant theta. Is that okay, everybody? What's the period? Also 2 pi, the same as cosine. So if you want to draw more, you just keep going and you can draw more. Is that okay, everybody? Yes? Okay. So yeah, you must know how to reproduce that, because you need to remember all of these for exam 3 next week. Okay, secant 1 over what? Sine theta. Yes? The special angle. Questions? Are we all good? Okay, so same angle, 0 pi over 2, pi, 3 pi over 2, and 2 pi. So we also need to draw the sine first. So it starts with what? 0. And then 1, 0, and then -1 and 0. Okay, this is sine. Secant, okay, sorry, cosecant. 1 over sine. Do you see here at 0? 1 over 0 is undefined. Right, everybody? So we have a vertical asymptote there. And at 1 over 1, right? And here 0, 1 over 0, undefined. Here 1 over -1 is -1. There 1 over 0 is undefined. And then therefore we can draw, so we are approaching to the asymptotes. So this is the graph of cosecant. Okay, everybody? Yes? Oh, how do you feel in those values? You see, at 0, 1 over 1 is 1. And then at pi over 2, undefined. At pi, -1. 3 pi over 2, undefined. 2 pi, 1. How about the cosecant? At 0, 1 over 0, undefined. Pi over 2, 1 over 1 is 1. At pi, we have 1 over 0, undefined. 3 pi over 2, 1 over -1 is -1. At 2 pi, undefined. What's the period? 2 pi. Okay. Now we learn the graph of all the 6 trig functions. Okay? Now, how do we solve the problem? The problem in the exam would be graph the trig functions. Okay? And when you're going to show your work, you do the table, 4 columns. X, theta, the trig function of the theta, and then the y value. And then you draw the graph. So you don't need to do the sequence of transformations. Is that clear, everybody? So let's do this exercise. Okay. Yeah, by the way, today we don't go over your worksheet 6.2. That's why I give this handout to you. We review all the trig graph and then we do this exercise together. But if you have time, you can look at 6.2 as exercise. I already posted notes with answers on the website. Is that okay, everybody? If you have questions, feel free to ask me. Yeah, like I said at the beginning of this semester, is that we have a lot to cover. So we might not able to go over every problems in your worksheets. Okay? But yeah, that's but if you have questions, come to ask me after class. Yeah, I'm happy to talk with you in more details after class because we don't have the we have the time limits in the class time. Okay, so 4 column x and then theta. In this case, what's my theta? 2x minus pi, right? Theta is the argument, like the angle inside the trig function. Yeah? And then here we use cotangent theta. And okay. Last one. What's my y? My y, you see, is -3 cotangent theta plus 4. Yeah. So you draw a table, 4 columns. Okay? So what do we do first? Well, the first step, you fill in the values in the theta column. Right, everybody? This is about what? Cotangent. Cotangent. Then you look at cotangent. What are the 5 key points? They are 0, pi over 4, pi over 2, 3 pi over 4, and pi. Yes? So this is how you use it. These are the 5 key points you need. Okay, 0, pi over 4, pi over 2, 3 pi over 4, and pi. Our cotangent values are, what are your cotangent values? At 0, you get undefined, and then 1, 0, -1, and undefined. Very good. Okay, so all those trig functions help you to figure out these two columns. Okay, the first step, figure out the theta. Second step, look at those trig functions, figure out the cotangent theta. And then step 3, figure out the x. So theta equals 2x minus pi. You want to solve for x. How do you solve for x? We add pi and then divided by 2. Is that okay, everybody? Okay, so plug in the different theta values. When we plug in 0, what's x? If you plug in theta is 0, what do you get? Pi over 2. And when you plug in theta, it's pi over 4. Okay, my theta is pi over 4. What's pi over 4 plus pi? Pi over 4. And then divided by 2. 5 pi over 8. Is that okay, everybody? Yes? Okay. When we plug in theta is pi over 2. What's pi over 2 plus pi? 3 pi over 2, right? But when you divide it by 2, what do you get? Yeah, 3 pi over 4. Very good. Okay, now 3 pi over 4 plus pi over 2, right? What do we get? What's 3 pi over? See, we're putting in theta is 3 pi over 4. We add pi to it and divide it by 2. What's 3 pi over 4 plus pi? 7 pi over 4. Divided by 2? Yeah, 7 pi over 8. Good. When we plug in pi, what happened? Pi plus pi over 2 is pi. Yes. So we figure out the x values. Now, step 4. What is our y values? See? By the way, if you plug in undefined, it's going to be undefined. Do you agree? So, undefined. Now we plug in 1. See? -3 times the cotangent is 1 plus 4. What do you get? That is 1. Right? Everybody? When you plug in 0, what do you get? 4. See, -3 times 0 plus 4 is 4. When you plug in -3, when you plug in -1, what do you get? 7. And when you plug in undefined, it's undefined. Right? Okay, step 5. You're gonna plug in your x and the y. Okay, so in that picture, you plug in your x and your y. Okay, so they are x and y. First point, let's see how big you need. Do you see you get at most pi, right? So you can adjust your scale. That's pi. So if your problem, let's see how far you get. Maybe this 3 pi, and then you get the furthest is 3 pi. Is that okay, everybody? And then at pi, the middle is pi over 2, right? And then the middle will be what? 3 pi over 4. Do you agree? And then the middle is 5 pi over 8. And here the middle, 7 pi over 8. And how do I get that? You see, pi over 2 and pi. And then the middle, 3 pi over 4. And then the middle of pi over 2 and 3 pi over 4 must be 5 pi over 8. And then this is the middle of 3 pi over 4 and pi. Is that okay, everybody? So those are the x values. Your y values. Undefined means dashed line, vertical asymptote. And then, what's the next point? You get 1. Yes, you get 1. Oh, because I need to get at most 7. So maybe my 1 is put it smaller. I need to get at most 7. So let's say this is 4, and let's say this is 1. Okay. So 1 is right here. And then what? We get 4. Yes, everybody? And then we get what? 7 right here. And then undefined. Connect them smoothly. When you connect them, you always start with the midpoints, okay? And then just you know your shape. You connect this, and then you're getting closer to the asymptote. So then you draw it like that. And then the other way, you connect them, and you get closer to the asymptote. So this is one period of the cotangent function, okay? And usually the problem in the exam will ask you to draw 2 periods. What do? You kind of plot it again, one more copy, right? So you plot it again, and then you draw. This is the 2 periods of it. Is that okay, everybody? And now, questions. What is the What's the period of this function? What's the period of cotangent? Pi. And then you use it divided by the coefficient of x. Is that okay, everybody? So you divide it by the coefficient of x in the angle, which is 2. Right? The coefficient of x inside the angle is 2. So the period is pi over 2. And you say, oh, really? Because the difference between pi and pi over 2 is pi over 2. So that's one period of the cotangent. So is that clear how to draw trig graphs? Yes? Okay. Let's do one more exercise. So in the exam, I will ask you to draw 3 trig graphs. So one of the sine, cosine, tangent, cotangent, secant, cosecant. So you're going to be familiar with all 6 of them. Okay? All right. Now, secant, do the same thing. So you have the x value, the theta, the cosecant theta. So the y is then 4 cosecant theta minus 1. Cosecant, what are the values you pick? Look at this. What are the values you pick? 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right, everybody? By the way, in the exam, do you want to have a copy of this blank sheet? Or do you want to have a copy of this blank sheet or not? Yes? Oh, because if you fill it out, maybe use 1 or 2 minutes to fill it out. If you're so familiar with it, you can try to fill it out. And then when you do your problem, you just look at this sheet. You don't need to think, oh, what is that? You just look at the sheet and then you can do it. All right. So 0, pi over 2, pi, and 3 pi over 2, and 2 pi. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. What are the cosecant values? What's the cosecant values? You get what? Cosecant, cosecant. Cosecant, right here. See? Undefined, 1, undefined, -1, and undefined. Cosecant, not cosine. Cosecant. Yes. CSC, cosecant. Right. So undefined, 1, undefined, -1, and undefined. Okay. So what is your theta? Negative x plus pi over 2. Yes, everybody? So what is your x? Well, let's see. So theta, step 3, theta is negative x plus pi over 2. Oh, do you see if we add x on both sides, we get x plus theta is pi over 2. And then we subtract theta on both sides, we get x is pi over 2 minus theta. Yeah, everybody? Okay, so x is pi over 2 minus theta. Look at here. Pi over 2 minus 0 is what? Pi over 2. And then here, pi over 2 minus pi over 2 is 0. And then pi over 2 minus pi is negative pi over 2. And then pi over 2 minus 3 pi over 2 is negative pi. And pi over 2 minus 2 pi is negative 3 pi over 2. Yes, everybody? Right? Okay, what's the next step? Figure out the y. Yeah? What's your y? When you plug in undefined, what do you get? Undefined. If you plug in 1, what do you get? You get 4 times 1 minus 1 is 3. When you plug in undefined, undefined. When you plug in minus 1, what do you get? Negative 5. And when you plug in undefined, it's undefined. So not many calculations, because 3 of them are undefined. That make it easier. All right, so you draw the x-axis and you draw the y-axis. Okay. Look at the x values. You see? Pi over 2. But this is the negative side. Negative 3 pi over 2. So, well, yeah. Okay. So, negative 2 pi here, and negative pi here, and negative 3 pi over 2 is here. Negative pi over 2 and pi over 2. Is that okay, everybody? Look at the x value. It is at smallest negative 3 pi over 2. And usually I draw a negative 2 pi, and then half of it is pi, half of it pi over 2, and then this is the midpoint, is 3 pi over 2. Negative. Yeah? And then, oh, pi over 2 right here. So plot the x values. Now, the y. The y, 3 and negative 5. They're important. So 3 is above, negative 5 below. Okay? Now we're ready. Pi over 2. Undefined means asymptote. So draw a vertical asymptote. Is that okay, everybody? Yes? And then at 0, we get 3. Okay? So at x is 0, we get 3. And then at negative pi over 2, undefined. So we draw vertical asymptotes. Yes. And then at negative pi, we get negative 5 down there. Negative 3 pi over 2, undefined asymptotes. Okay, now you remember, how do we draw secant? Okay, so this is how I think. Sine, cosine, wave. Your hand, move with me. Wave. Okay? And tangent, secant, so like that. Like a cube function, x cube, like that. Right? Okay. And then secant and cosecant. Up, down, up, down, up, down. Exactly. So then, what do you think this guy? Up or down? Up. Yes. So we draw up. How about this guy? Down. Exactly. Right. So this is one period. You want to draw another period. So you look at this distance. Okay, so it's about like that piece. We draw it. And about that distance, we draw it. Okay. Tell me, this guy up or down? Up. So therefore, it's about the 3 point. Okay, up. And this up or down? Down. Exactly. Very good. So this is the two periods of the cosecant graph. What is the period? You use the period of cosecant is 2 pi, but do you see the coefficient of x is -1? If the coefficient is negative, you divide it by the absolute value of it. So which means it's the same thing. Your period is always a positive number. Okay, everybody? Yes. So let me put it down. If coefficient of x in the angle is negative, put absolute value. Your period is always positive. You don't have a negative period. Okay, everybody? Okay, so by the way, let's think about transformations. What does the plus pi over do to it? Our parent function is cosecant x, right? So we shift left or right? Left pi over 2. And then what does the negative sign in front of x do to it? Reflect over the y-axis. Very good. And what does this 4 do to it? Vertical stretch by a factor of 4. What does the -1 do to it? Shift down 1 unit. Okay? But right now, you don't need to do those transformations because it takes a lot of time to do it step by step. Just draw the table and boom, draw one graph. Okay? Is that clear, everybody? Okay, so yes, let's save that. And okay, now let's look at 6.3. Let's do from the last page. Okay? Do the last page. Oh, okay. So before that, let's talk about inverse trig functions. So inverse trig functions. Sorry. Let's go back to this piece. Okay. What does inverse trig function do to it? Let me use orange color. Okay, orange color. So inverse trig functions. You know, inverse function, they are reciprocal. They are mirror image about the line y equals x, right? So this is y equals sine x, and then the inverse function will be arc sine of x. Okay, another notation arc arc sine of x. They mean the same thing. So this is inverse function. How do we figure out the inverse function? Well, you first restrict the function to a one-to-one piece. Okay, so a function is 1 to 1, and then you can have the inverse function. But in this case, because the sine is not 1 to 1, you restrict. So you restrict the angle. So we restrict from minus pi over 2 to pi over 2. You restrict to this piece. Do you see on this piece it's now 1 to 1? Okay. And what do? So you draw the line. This is y equals x. And then you draw the mirror image about the line. Therefore, this point at pi over 2 to 1, the mirror image about the line will be here. Then this new point, okay, so let me draw another one. This new point is at 1, and this is pi over 2. And then 0 is still 0. And then here, this point, the mirror image will be here. So you kind of switch the x and y. So therefore here, you get -1 and negative pi over 2. Okay, so you have this point. This point becomes this point. And then when you draw them together, you get, this is the inverse sine function. So this is the graph of the inverse sine function. Is that okay, everybody? We do the same thing on cosine. By the way, the note of this sheet at the end, I will post it at the bottom of our website, the answers. Okay, so if you miss something, you can fill it out after class. Okay, restrict to 1 to 1 piece. So the restriction we do is from 0 to pi. So this is 1 to 1. And then add cosine. Okay, both notation are correct. We now do the what? Flip to the mirror image about the line y equals x. Then this point is about here. This point is like there, and then this point is like here. Okay, so you get something like here, here, and here. So this point corresponds to 1 and 0, and then here this point 0 and pi over 2, and that point -1 and pi. So this is the graph of arc cosine. Is that okay? How about tangent? Okay, tangent. What's the graph of arctangent? Well, you pick the 1 to 1 piece, and then you flip it over about the line y equals x. Therefore, you get, you see, we get horizontal asymptote now. And then this point now it becomes here. Okay, so now it becomes here. And then 0 is still 0. And then this point now becomes here. Okay, and then when you connect them together, this is the graph of arctangent. Is that okay, everybody? Yes. How about the graph of arcotangent? Well, you restrict to the p0 to pi. So arcotangent okay, from 0 to pi. So you flip across the line y equals x. This point goes here. And then this point will go here. Right? So therefore when you draw it, this point go here, and this point will go here. So this is the graph of arcotangent. Is that okay, everybody? Yes? Yeah, draw the mirror image of that. Okay, now how about arcsecant? So as secant, you look at the 1-to-1 piece. So the 1-to-1 piece is right here. From 0 to pi. Okay, so y is at secant. Okay. From 0 to pi. So 0 to pi. And then you flip across the line. So see, this point now becomes here. Okay, so it becomes here. And then, oh, you also have an asymptote here. So, and then this point now becomes here. Okay, so this point becomes here. Therefore, you get, this is not a asymptote there. Yes, this point becomes here. So this is at -1. This is at 1. Okay, so this is the graph of secant x. Is that okay, everybody? How about cosecant? Well, the 1-to-1 piece, you actually pick here. So this is the piece you pick. So y equals cosecant x. Okay, that is from, now this is from let's see, -2. Okay, so -2 to power 2, right? And you want to, okay, flip it over the line y equals x. Therefore, this point is about there again. So you still have this point here. This is at -1. And that point still there, so this is 1. And you get something like that. So this is a graph of cosecant. Okay, everybody? So what I usually do is I draw the trig function, and then I can do the mirror image across the line y equals x to figure out the graph of the inverse trig function. Okay, everybody? Yes. So in the exam, I won't ask you to draw the graph of the inverse trig function. Okay? But this is how we can use it to graph it. All right. In the exam, I will ask you the following. Find the exact value of the following expression. Do not use calculator. Draw a triangle and solve it. So what do you do first? You call this theta. That one, call this theta. And this means theta is arcsine of 2/5. Well, what does that mean? That means, well, to get rid of the arcsine, you apply sine on both sides. So sine and arcsine, because they are inverse function, they cancel. You get sine theta is 2/5. Okay, so step 1, yeah, figure out your theta. Step 2, draw the triangle. Draw your triangle and you put this left lower angle to be theta. Sine. Sine is what? Opposite adjacent hypotenuse. What? What over what? Opposite over hypotenuse. So that means your opposite is 2. Your hypotenuse is 5. 3. By the Pythagorean theorem. What's this guy? Square root of. Exactly. What's 5 squared? What's 2 squared? Oh, do you see we got 21? Last step. What are we looking for? We're looking for tangent theta. See? We're looking for tangent theta. What's tangent theta? Opposite adjacent hypotenuse. Yeah. What's opposite? What's adjacent? Yes. Very good. So 4 steps. Step 1, define your theta. Okay, theta is whatever that inverse trig function is. And then get rid of the inverse trig function. And then sine opposite over hypotenuse. Draw the triangle. Write down the corresponding sides. Use the Pythagorean theorem to find the length of the remaining sides. And then we're looking for the tangent theta. Is that okay, everybody? Okay, so how about the next problem? What's your step 1? Call this be theta. So that means theta is cosecant, inverse cosecant of 3x over 7. What does that mean? How do you get rid of the odd cosecant? You apply cosecant. That equals what? Yes. So triangle. What's cosecant theta? Opposite adjacent hypotenuse. Cosecant is 1 over what? What's the reciprocal? Sine. So sine is hypotenuse over, sine is opposite over hypotenuse. So then this is hypotenuse over opposite. Okay, hypotenuse is 3x. Opposite is 7. What's the remaining sides? It'll be what? 3x squared minus 7 squared. Ooh, what's that? Is it 9x squared minus 49? Okay. Yeah, it might be ugly. Just leave it like that. Cotangent. What's cotangent? Opposite adjacent hypotenuse. Cotangent. What's cotangent? Adjacent over opposite. Yes. So please make sure you remember all these on the sheets. Okay? Yeah, that's very, very important. Adjacent, what's your adjacent? Well, that's square root of 9x squared minus 49, right? Opposite. Bless you. Opposite is 7. Okay, everybody? So 4 steps. Figure out that angle that is theta, and then find the trig function to get rid of the inverse trig function. And then draw the triangle. Use Pythagorean theorem, and then find out our desired trig functions. Okay, everybody? All right. We still have little time. I want to just briefly talk about the other problems in this session 6.3. Okay? So, how do we compute the inverse trig functions? Well, you know your calculator, it has the arc tangent, arc sine, and arc secant, right, everybody? So if you want to compute like arc tangent of some number, you just type it in. But if you want to compute arc cotangent, remember cotangent is the reciprocal of tangent. So this is how you compute. You put arc tangent of reciprocal, 1 over 215. Okay, everybody? And arc cosecant is the reciprocal of sine. So arc sine of 1 over that. Okay, so this is how you compute that using your calculator. What else? Yes. Oh, special angle. So how do you find y without a calculator? This means tangent y is square root of 3. Therefore, your y is pi over 3. Okay, no decimal, no calculator. So you apply tangent on both sides, and you figure out the common angle. Okay, how about tangent of 1? So that means tangent y is 1. What angle gives you tangent of y equals to 1? That is pi over 4. Okay, everybody? And half or minus 1? Ooh, negative pi over 4. And square root of 2. So tangent y is square root of 2. But this is not a common angle value. You have to use your calculator. Okay, everybody? So it depends on whether they are the common angle value, then you can figure out. And similarly, but be careful, you know the sine and cosine, they are bounded between 1 and minus 1. So if you have cosine of some angle equals to 2, that is impossible. The sine is only bounded between minus 1 and 1. So therefore, no solution in this case. Okay, so yeah, 6.2 and 6.3, I have the notes with answers on our website. So I hope you can read through those. If you have questions, ask me. So I really need your help, okay? So we do those. Spend more time practicing. If you have questions, come to ask me. I know we have limited time. So if you have questions, come to ask me, and then I'm happy to explain to you in more detail. Review session is on Wednesday, 8 p.m. Okay, I will also make it part. Yeah. Questions? Oh, the period is pi over the coefficient of in the angle argument. So we call this angle being the argument. And then this is the coefficient too. The number multiplied. Oh, so the period, so cotangent of period is pi, right? And you use it to divide it by the coefficient of x in that angle. So this is how we find it here. Mm-hmm. Hi. Oh, questions? Okay. Ah. Yes. This is article. Right. I already submitted that with the other sheet. Okay, so I'll submit another. Like, get one more copy, so we bring it there. And okay. How about I write it down? So. This blank. Okay, so then there you go. Okay, thank you. Hi.
Majority of the concepts in chapter 6.
Oh.
Is there any chance we can meet you tomorrow?
Sure. So I have office hours from 11. Let me check.